Assalamualaikum, my name is Muhammad Amin Zaid bin Rusdi and my student ID is 2025394889, and today I will be presenting about my Stack and Queue Java project, which is the AMV clothing inventory system. So in this video I will talk about the classes that I have built and show you guys some demo of my project. So without further ado, let's get started.
Okay, now let's take a look of the first class, which is the AMV clothing class. So this class is very important for this project because it is basically a blueprint of the data that we're actually managing. So nothing much has changed since our first assignment, which is the array list and the linked list assignment. We're still using a standard object class that encapsulates all the attributes of the single inventory item, which is the ID, names, category, size, price, and stock. So I've implemented private attributes for encapsulation and set a public getter setter methods to access them safely. So crucially, I've overridden the toString method here. So this ensures that when we print a clothing object in our main application, it formats itself into a readable block of text automatically. Okay, now let's take a look at how we store these objects. And since this is an inventory system, so order is really matter, and I already implemented a queue class that inherits from the linked list. So in this queue class, it follows the FIFO principle, which is the first in and first out. So as you can see, the enqueue method I call insert@that, which stimulates the real world queue situation where new items joins at the end of the line. And then we have a dequeue method which calls remove from front, ensuring that we process the items in the exact order that they have arrived. However, for categorizing specific stock like the all stock, a queue class is not the right fit for that. So in the program, I implemented the stack class. So the stack class follow the LIFO principle, which is last in and first out. So notice the difference in the push method. Unlike the queue, here I call insert at front. So by adding a new items to the head of the list and removing from the head using pop. So we create that stacking behavior where the most recently added item is the first one that we access and remove. So as you can see here, I also added a pick method which allows us to check the top item without removing it. So this is a feature that becomes critical for our algorithm section later. So now let's take a look at the class structure of AMV for main. So in this class, I have declared my data structure as a static global variable. So here we can see that all clothes is a queue. I choose queue here because when we load data from a file or add item, we generally want to process them in the order they arrive. So we apply the principle of first in and first out, which is FIFO. So here you can see that new clothes and old clothes is a stack. So this create a LIFO behavior for specific categories. So this stimulate a pile of inventory where the newest addition is on top. So you also have noticed that I have temp-q and temp-s, which are very important. So unlike an array, you cannot just pick at the middle of stack or queue. So to read the item, you have to empty them. So this temporary structure holds the data while I traverse the main list. So it allows me to restore the data afterwards so nothing is lost. So here in the main method, I handle file input and output. So I use a file and scanner classes to read the clothes.txt file, and I look through the file line. So here I use a string tokenizer to split the text by the semicolon delimiter. So in the main method, as soon as an object is created, I perform two actions. The first one is I enqueue it into the all clothes, the master record. Second, I check the logic of the category. So here, if it's a new item, I push it into the new clothes tag, otherwise to the old clothes tag. So the first method in the program is the main menu. So it will display all this menu so that user can enter their option. So after users have entered the number of menu that they want, the system will use a switch case option by determining all the function by the number that user have key in the system. So here is the display item method, which is the first method in the menu. So here The display all item method demonstrates how to traverse a queue without destroying the data. Since all clothes is a queue, I use a for loop that run as long as the queue is not empty. So the first thing that we can see that happens in the loop is that I dequeue the head item from all clothes, and then I print it by category, which is the new category or all category, and then I immediately enqueue the same item into temp queue. So now let's move on to the second method in the menu, which is the search item method. So searching follow a similar pattern to display. So first I dequeue items one by one. So inside the loop I check if object.getId equals ignore case search. If it matches, I flag it as found, and regardless of whether it matches, I send the object to temp queue to ensure it is preserved, and after the loop I restore back the queue. Now we will take a look at the most complex algorithm here, which is the delete item method. So deletion is the most complex because I have to remove the item from both the master queue and the specific category stack. So for the stack deletion, if the item I want to delete is at the bottom of the stack, I cannot simply reach it directly. So here I need to pop the item off from the top stack and push them into the temp S, which is the temporary stack. So I will keep doing this until I find the target item. So when I find the target, I simply do not push it to the temp stack, so it will effectively disappear the item. And lastly, I pop everything from the temp S back to the main stack to restore the original order of the item. So let's look at how we handle the new inventory with the add new item. So in this method, it is a perfect example of how we keep our data structure synchronized. And firstly, we can see that I use a scanner to collect all the raw input from users, such as the ID, name, size, price, and the stock count. So once I have those variables, I instantiate a new LMV clothing object. So now this is the most crucial part. I have to make sure this new item exists in both of my inventory system. So first, I immediately call allClothes.enqueue. So we use enqueue here because allClothes is a queue. So this puts the new items at the back of the master list. So it will preserve the history of when the items were added. And then I check the category, and if the user type new, I call the new clothes.pushAMV. If they type all clothes, I call the all clothes.push.amv. So it will store in both of those methods. So let's take a look at the move item function, and this function is very unique because it physically moves an object from one data structure to another. So the first thing that the system will do is will search for the object, and if they have found the object, it will ask the user to enter a new category for the cloth, for example new or old category. So and then we use a remove from stack method to delete it from the current stack, and then we update the category string for the object itself, and then we will push that same object onto the destination stack, for example new clothes to all clothes. So in this method, it simulates the real world action of taking a shirt from new arrival item shelf and moving it to the clearance pile, for example. So now we take a look at the statistic method. So in this method, we will iterate through the entire all clothes queue. So in the loop, we can see that I maintain counters for count new, count old, and running totals for prices. And I also perform a standard min and max algorithm where I initialize the min to the maximum possible value. So the other line of the code is just an infits to postfits converter method and exit program method. So we'll get more into the infits converter in the next class. So finally, we have the infits postfits conversion class. So this class is basically just a bonus mark for this assignment. It's not related at all with the inventory system, but this class demonstrates a practical use case for the stack data structure. So in this class, it contains a static method called infits to postfits that takes a standard mathematical expression like a plus b and converts it to a format that a computer can easily evaluate. So the main logic in this class is rely on the stack. In this method, it loops through the input string one character at a time, and if it sees a letter or a number, it knows that data, so it will immediately add it to our result string. However, if it's encounter an operator like a plus sign or minus sign or multiplication sign, it can't just add it to the result yet because order of operations matters, and this is where the stacks come in. We push this operator into the stack to hold them for later. And before we push a new operator, we check the importance using the precedence method below. So if the operator already on top of the stack is stronger, for example, if there is a multiplication sign waiting on the stack and we are currently looking at a plus sign, we will pop that multiplication of the stack and add it to the result first. So this will ensure that the multiplication happen before addition, respecting the mathematical rules. So we also handle parentheses here. If we see an opening bracket, we will push it, and if we see a closing bracket, we pop everything off the stack until we find the matching opening bracket. So this will effectively solve the expression inside the parentheses first. So once the loop finish, we simply pop any remaining operator left in the stack to complete the conversion. So right now we are going to demonstrate the app, so to see if it's the function and all the method work. So let's get started. So the first thing that user will see when they run the program, that they will be welcomed by this message terminal. So then we will hit enter to go to the menu, and in this menu you can see we have 8 different choices of menu. The first one is to display all items from the close.txt file. So we'll try to display all the items by clicking one, and it will display a new stock and old stock in a table view so that user can understand and have a better view of the stock in every category. To go back to the menu, we hit enter, and we will try to do the menu 2, which is search for an item by product ID. So for example, I want to search for an blue shirt in the new stock. So we're just gonna type 2, and here it will ask the user for the cloth ID. So we enter the blue shirt ID, and then it will display all the items details about the shirt. So here we have the product ID, name, the category, size, price, and the stock count, and we hit enter. So before we delete an item by product ID, I want to show you how we can add a new item to the list. So we hit 4 to add a new item, and it will ask the user for the new cloth ID, and we will just type in a random ID, so T019, and then we give a name to the cloth. We set the category to new, the size and price 200, let's say, and the stock count is 1. So it will display a successful message that means we have successfully added the item to the new list. So now if we want to check if the item has been inserted into the list, we can just press 1 to display all the items, and now you can see that we have T019 in the new stock, so that our function works well. And then we hit enter back to the menu, and so now let's say we want to move the new item that we just added to the new list to the old list. So we can just hit 5 in the menu, and then it will ask the user to enter the ID that we want to move. So for example, I want to move the T90 product, which is the Nike Pro, and we hit enter, and then it will display the current category of the product, which is new. So now we want to move it to the old list, and then it will pop up a message that says the item has been moved successfully. So to validate this, we're gonna see the list of the items. So and now we can see that the Nike Pro product is already in the old stock list. So the function works really well. Besides all that menu, we can also access the statistic menu, which is it will display us and give a brief overview of our item average price, maximum price, and minimum price. So as you can see here, the maximum price is the newly product that we just added, which is the Nike Pro that is priced for 200. And let's say we want to delete an item by product ID. So we hit the number 3. So let's say I want to delete the Nike Pro. So we enter the product ID. So it will automatically delete the item from the list. So to validate this, we will take a look at the item list, which is the menu 1. So now you can see that the T90 has been already moved from both new stock and old stock list. So the function works. And for the last function that I want to show is that the expression converter. So we hit 7 on the menu, and then it will ask us to enter an infix such as a plus b minus 1 or anything. So we're just gonna key in the infix. So let's say a plus b divided by 10 minus 20, and it will give the postfix of the infix. So notice that all the operands are put behind the numbers and the letters. So this function works well. And let's say for example I type an incorrect order of operand, it will not give the output of the postfix because it is an invalid expression, because our input starts with a close bracket. So the system will ask us to input the correct order of the infix. So we hit enter to exit the infix converter program, and to exit the program we just hit the number 8 and it will display a thank you message.
So this is the end of the video. I hope you guys enjoy it and maybe learn something new from me. And thank you so much for watching, and I guess I'll see you next time.